Hey guys, Rhett here. In the video today, I'm going to find the equation of three different parabolas. So the first one here is shown in green, the second one here in purple, and the third one in pink. For this first graph in green, I have the x-intercepts shown here at 2 and 4. And I'm also given the y-intercept up here at 0, 4. So I'm going to go ahead and use what's called the x-intercept form of the parabola. Y is equal to a, x minus e, x minus f. And I've just noted down those points, the x-intercept at 2, 0, 4, 0, and the y-intercept at 0, 4. So using this generalized form, y is equal to a, x minus e, x minus f. I simply substitute in the two x coordinates, a x minus 2, x minus 4, and now I'm going to use the last piece of information, the y-intercept, so sub x equals 0, y equals 4. This is going to allow me to find a. 4 is equal to a, negative 2, negative 4, which then implies that a is equal to 1/2. So therefore, the equation for this first parabola, y is equal to 1/2 x minus 2, x minus 4. The second parabola, here in purple, this time I've got down here its turning point at 3, 1, and a y-intercept up here at 0, 19. So I'm going to go ahead and use what's called the turning point form of a parabola. Y is equal to a, x minus h all squared plus k. So I've noted down here from the graph the turning point at 3, 1 and a y-intercept at 0, 19. So the general form, y is equal to a, I'm going to substitute in the turning point, so x minus 3 all squared plus 1. Similarly to before, to find this a, I'm going to sub x equals 0, y equals 19. So I get 19 is equal to a, 0 minus 3, so negative 3 all squared makes 9, plus 1, which then implies that a is equal to 19 minus 1, 18, 18 divided by 9, 2. So therefore, the equation of the second parabola, y is equal to 2, x minus 3 whole squared plus 1. And finally for the third parabola, so this one's a little bit more complicated because I am given 3 points on the graph. So the first one is up here at negative 1, 10. I have this y-intercept at 0, 5, and I have another point just here at 1, 4. So in this example, I've noted down the generalized form for a parabola, y is equal to ax squared plus bx plus c. And then in purple, these are the 3 points from before. So to solve this one, I'm going to have to set up a series of simultaneous equations and then use elimination to figure out a, b, and c. So I'm going to sub each point into this generalized form. So the first one, the point is negative 1, 10. So I have 10 is equal to a minus b plus c, and I'm going to call that equation 1. The next one, 5, is equal to a times 0 is gone, b times 0 is gone, is c. So that's essentially my y-intercept. C is 5. And the last one, 4, is equal to a plus b plus c. So now I have 3 equations with 3 unknowns. Note from the second one that I know straight away that c equals 5. I'm going to substitute equation 2 into equation 1. And rearranging, I get a minus b is equal to 5. I'm going to call this equation 1 dash. And substituting c equals 5 into equation 3 gives me a plus b is equal to negative 1. I'm going to call that 3 dash. I'm then going to add 1 dash to 3 dash, which is going to give me a plus a is 2a. The negative b and the positive b is going to cancel, so that's good. That's my elimination step. 5 plus negative 1 is 4, which then gives me a equals 2. I'm going to substitute a equals 2. Now I can choose either 1 dash or 3 dash. I'm going to use 1 dash. 2 minus b is equal to 5, which then gives me b equals negative 3. So therefore, the equation of this parabola, y is equal to 2x squared minus 3x plus 5. That's the end of the video, guys. Thanks for watching. Feel free to like and subscribe, and as always, good luck with methods.